here I'll be showing you two examples of a case where we have the QSR1 on a pipe without cups and another case with cups. Okay. Here, as you know, the QSR1 has both a transmitter and a receiver. The transmitter is transmitting SH guided waves, which includes SH0, SH1 guided waves. As you know, when we transmit the guided waves, the waves will travel in both directions. Okay, so like so. In other words, we often refer to it as the top path, okay, and the bottom path, or in terms of letters, we call this the A and the B path. Okay, that's what we are referring to when we say A and B. Okay, so imagine that we can only see the guided waves that are going in the top path or the A. Okay, so let's just look at this plot over here, and we can see that in the top path that the SH0 guided waves is propagating, as well as the SH1. All right, and path A represents the top path over here. Okay, and of course there's also the bottom path direction. So if we are able to isolate these waves and just visualize just the bottom path guided waves, then we would see the B path SH0 and the B path SH1 are arriving a bit later. So you can see that they are arriving at different times. Okay, because the distance of A and B are not the same. So the path of A is shorter than the path of B. Okay. Now, in reality, guided waves are being transmitted at the same time and they're being received at the receiver. So in reality, we will see both A and B paths in the time domain. Okay, but you have to also recall that the guided waves, once it travels to the receiver, okay, it will continue to go around again. So the waves will continuously go around this pipe circumference. So that is what we mean by C. Okay, so A plus C basically says is the time or the path where we have A path plus a full circumference. Okay, so similarly, B plus C is the B path, the bottom path, which has gone full circumference, pipe circumference. Okay, let's clear this quickly. All right, and here we have the same time domain plot as before, where we can see all the arrivals of the guided wave from different paths. Now this is the time domain. Okay, essentially we are plotting amplitude as a function of time, but of course through Fourier analysis we can convert time domain signals into frequency domain signals. Okay, and here we have a plot of frequency against time or distance. Okay, and as you can see, we are seeing the frequency components or spectrum of each of these individual guided wave modes. Okay, so here we can see the SH0 from the A path, and we can see the SH1 from the A path. Okay, and so on and so on. So in the second scenario, we have the case with cups in the pipe. Okay, if we first of all look at the results from the path A only, we realize that there is an extra bit of signal that appears later after the first typical path A results. If we compare that to a case with the good pipe, a good pipe only, you notice that there's no extra reflection over here. Okay, and this is caused by the reflected SH1 caused by the reflection of the path B signal. Okay, so I'm going to draw it out to illustrate the point. Okay, so imagine the path B signal going down, okay, and there is a reflection that occurs because of the defect, and therefore this reflected SH1 comes back in the opposite direction, so it goes from B to the path A direction, so the reflection is going back towards the receiver like this. Okay, so this orange path here, which is reflection from the B path signal, okay, is causing this pocket of signals, this pulse of signal here. Okay, and if we look at the B path, we notice that the shape of the signal has changed. Okay, and this is because of a filtering effect. So the defect over here is only allowing high frequency signals to go through, and the low frequency signals are being reflected back. Okay, we will see that more clearly in the frequency domain. Okay, and as in reality, in practice, we will be seeing all of the signals arriving at the same time. Okay, so if we go to the time domain, frequency domain signal, we can see that the transmitted SH1 from the B path, okay, which is like this, okay, has only the higher frequency components that has gone through. Okay, the lower frequency has been reflected back. So we can see here in the reflected SH1, we can see that the lower frequency components has come back as a reflection. So the B path comes here, the lower frequency gets pushed back in the A direction. Okay, so that is what we see. So let me summarize again. So this reflection over here is caused by the B path signals, the SH1 signal that gets reflected from the CUPS defect. Okay, and this transmitted SH1B signal has only higher frequency components because this B path signal has gone through the defect and only higher frequency signals remain. Okay, the low frequency has been reflected back. Okay, if you have any other questions, feel free to email me again. Okay, see you.